right, on the things that's labeled Thursday and Friday homework, the first thing that you're asked to do is solve each equation by factoring. Okay, so remember that basically the question for Thursday and Friday homework is what's factoring good for? And it's good for two things. It's good for solving equations that are quadratic equations, and it's good for finding the zeros of the graph, right? Finding where the quadratic equation crosses the x-axis. So that's kind of one of the important things. Why should you bother learning to factor? Not only is it good to know how to do the opposite of multiplication, but it's also good to be able to solve quadratic equations and find the zeros or the x-intercepts of a quadratic graph. So the basic idea is that if you know the factors, you can set them both equal to, and it's equal to 0, then you can set them both equal to 0. So if you notice, this one's already factored, this one's already factored, and this one's already factored, this one. So these four, the hard part is done for you. You just need to set them equal, the different factors equal to 0 and find the different answers. It's down here where you need to go through a couple of steps. So I'm going to do problem number 6, and then your job is to finish the rest of them. So problem number 6, first step, I don't have a quadratic equation equal to 0. So if you want to solve by factoring, you're using the zero product property. You need the equation to be equal to 0 first. So I'm going to get this equal to 0. If I take 5 away from this side and I take 5 away from that side, I've left the equation balanced. So now I have a quadratic equation that's equal to 0. But it's not in factored form like this equation up here. So now I need to get it in factored form. So again, that's just like the other homework. Make a box, right? And now to factor, I work from the inside out. So I make sure it's in standard form. This goes in the first box. This goes in this bottom right box. So top left, bottom right. And now I know that what goes in these boxes has to sum to 7 in. So remember, sum is down here. But what goes in these boxes has to multiply to 10 in squared. These two, right? So you multiply these two together to get what it multiplies to, and this tells you what it sums to. So now it's just a puzzle. I need to find a pair that adds to this but multiplies to that. So I like to do systematically. I could just think through it. So this is one of those, you know, in the other video I showed you, I listed it systematically. 1 times 10, 2 times 5, right? But when it's this small, sometimes you can just think of it off the bat. I know that 2 times 5 multiply to 10 but add to 7. So I'm going to say 2 in and 5 in. And I need those ins, right? Because they need to be like terms to add up to 7 in. And it needs to be in times in to be in squared. So 2 times 5 multiplies to 10. 2 plus 5 adds to 7. And I need those ins. In times in is n squared. In plus n is, you can combine that. So now I found out what goes in these boxes, right? So the next step is find out what goes on the outside. That's the big step in factoring. Find out what goes on the outside. That's what we're looking for. So I find the common factor. What goes into both of these terms? Well, in is a common factor. There's a 1, right? So I can write the 1 or I can leave it. So once I know in is here, then I ask myself, well, what do I have to multiply here to get what's in this box? I would have to multiply in times in to get in squared, right? What would go here? Well, I'd have to multiply in times 2 to get 2 in. What would go here? Well, I'd have to multiply in times 5 to get what's here. And then just to check my work, 2 times 5 is 10. So I'm pretty sure I did this correctly. Okay, now I've got my factors. I need to write it in factored form. In plus 5 and in plus 2. And it's still equal to 0, right? So notice that now this equation looks just like these equations. So if you're trying to do these, you can pick up from this instruction here. So at this point, you know the factors and you know they're equal to 0, so you just have to set each factor equal to 0. I know that if n plus 5 equals 0, then I'll find one of my possible solutions. So what number does n need to be to make this 0? Well, if n is -5, that's one way to get this quadratic equation to go to 0. But there's another way, n plus 2 being equal to 0. So I subtract 2 from both sides, n equals -2. So if I put n equals -2 in here, that would make this go to 0, which makes that go to 0. If I put -5 in here, that would make this go to 0, which would make the product 0. So either of these n values work. This is what we're getting to, the whole point. The beginning equation asked us what n would make this equation true. Well, it turns out -5 and -2 would make it true, and we used factoring to help us figure that out. Now, we can also use factoring to figure out stuff about graphs, right? So notice that here they took y equal to a quadratic equation and they graphed it, right? And then based on the graph, what are the roots of this equation? So this graph and this equation are related. This equation is basically saying, where does this equal 0? When does this equal 0? Well, it equals 0 when y equals 0. Right here and right here, right? So it equals 0 at -6 and at 3. So -6 and +3. So when it says what are the roots are just a different way to say the solution, right? Or the zeros. Here we call them zeros or x-intercepts, right? Those are all different vocabulary words that kind of mean the same thing, right? So the idea is if you graph an equation, so one method we can use is of factoring, is find these answers. Another method we can use is we can graph the equation, find the zeros, and those will give us the roots of this equation. So we can use all those in together. So you should be able to find the roots of this one, and here you should be able to use your graphing calculator, right? And if you graph this, use your graphing calculator. Please be accurate. You need to really use your graphing calculator. You can trace it. You can find a table and find points to plot, but you need to plot an accurate graph. Once you plot that accurate graph, you will clearly see what the roots are, what the zeros are, and you'll be able to answer this equation. So the main idea here is being able to take the idea of factoring and solve equations, relate it to graphs, and how to use the graph to solve the same equations.